Working around electrical systems and equipment may be a daily occurrence for many Alcoa employees. Others may encounter electrical systems only periodically. Anytime you are exposed to energized electrical systems, the consequences may be severe if potential hazards are not recognized and controlled. That's why electrical safety is such an important element of Alcoa's fatality prevention effort. It's critical that our employees and contractors know how to protect themselves against electrical hazards. The first and most important step is learning to recognize the hazards and developing appreciation for the risk. If you know what potential electrical hazards exist, where they might be present, and what steps you need to take to avoid them, you are better prepared to work safely. Second is following proven and tested safe work practices step by step consistently. And third, having the self-discipline to observe arc flash boundaries and wearing the required personal protective equipment whenever you are required to be in areas with potential electrical hazards. While other layers of protection are designed into our electrical systems and equipment to prevent an electrical incident, protective clothing plays an important role in providing you with an additional layer of protection should something go wrong. And things can go wrong. For example, in the United States alone, 5 to 10 times per day, someone is severely injured or killed in an electrical arc flash incident. Other electrical incidents such as shock or electrocution are a result of accidental contact with energized parts. One thing is for sure: the consequences of shock and electrocution, serious injuries and fatalities, are devastating to the individuals involved and to their families. And all too often, the potential for disaster is present when it's least expected, while performing routine, day-to-day tasks.
It wasn't unlike just a few days before, because there was 3 furnaces, and we had done another furnace earlier that week. We went out there, removed the lock, signed off the paperwork, energized it, totally uneventful. As we were walking out, I said, uneventful's a good thing, you know. Didn't expect anything to happen, nothing happened. And this day, you know, same scenario, Ron came in, ready to unlock another circuit breaker. We went out there, we unlocked it, and this time when he energized it, it went boom.
When I pressed the lever to turn on the circuit breaker, I experienced a loud bang, a lot of smoke, and some sparks flew out and hit my arm. My first reaction was to make sure that I was okay and none of my clothing was on fire or anything.
There was a loud boom, I mean louder than a shotgun when he energized it, and it was a surprise. I mean, we just didn't expect that.
I was wearing the face shield, which attaches to the hard hat to protect my face, and I was wearing overalls that are flame retardant, and I had on the rubber gloves, voltage rated, with protective leather covers on those.
Yeah, Ron had all the right gear on. In fact, I thought he was overdressed for the job.
A lot of smoke billowed out the top through the vents in the top of the switchgear, and but everything was, except for the small interface between the shield and the circuit breaker, everything was contained.
Well, initially it was just the shock of what happened. You know, why did this happen? Because it was so unexpected. Because this circuit breaker feeds switch disconnects downline, and those disconnects were open. So there was no load on this circuit breaker, so it wasn't expected at all that there was a problem.
We started looking at the breaker and components that we had to figure out what actually happened. Apparently they were struggling with it when they installed it, and you can see that when they put it in, this sharp component right here had cut into the boot on the insulator. So when they inserted the lug into the breaker and tightened it down, even though we tested it to make sure there weren't any grounds there, either the stress from turning on the breaker or the energy available jumped that gap in there and created the arc flash.
Electricity exposes us to 3 primary hazards: shocks, arc blast, and arc flash. Most of us are aware that a shock is the unwanted flow of electrical current that creates sudden stimulation of nerves and the convulsive contraction of muscles caused by electricity passing through the body. And that shock can occur with contact or approach to live parts. But what about arc flash and arc blast? An arc blast is best defined as the rapid buildup of pressure which causes an explosion. Nearby material, such as copper, is melted, vaporized, and thrown into the superheated air like shrapnel. An arc flash hazard is the release of dangerous energy caused by an electric arc. Unlike electrical shock, contact with an electrical energy source is not necessary. Persons some distance from the source can suffer serious burns when an arc flash occurs, releasing massive amounts of energy, extreme temperatures, molten metal, shrapnel, and deafening sound. A misconception is that the magnitude of the arc is based upon the magnitude of the voltage. In fact, more than half of all arc flashes occur at only 277 volts. Electrical accidents represent one of the leading risks for catastrophic or critical injuries at Alcoa. In fact, since 1963, 25 Alcoa employees and contractors have died in electrical mishaps. All it takes is one simple error in body positioning, a slip of a hand tool, an electrical component failure, or a seemingly minor deviation from a safe work method. Because an arc flash occurs in less than 1/100th of a second, it is physically impossible for you to realize what is happening, react, and get out of the path of an arc flash once it is initiated. And burns occur in less than 1/10th of a second. At Alcoa, we rely heavily on two crucial electrical safe work practices to protect you from exposure to arc flash hazards. They are shielding. For example, enclosed switchgear and wearing the right personal protective equipment for the task or exposure. And distance, maintaining a safe working distance from the potential hazard. Alcoa Standard 3270 Safety Practices and Requirements for Electrical Arc Flash Hazard Protection outlines the personal protective equipment required when working near an arc flash hazard. The second way you will know the required distance is through the use of warning labels. These labels give you several important pieces of safety information. They communicate the voltage and the arc flash hazard boundary. According to this label, you are to stay at least 4 feet away from the equipment while any task is being performed that might initiate an arc. In general, that means a 4-foot boundary must be maintained any time work is being done involving that piece of equipment. Or you can use tools and devices to reduce a level designated piece of equipment down to level 2. Arc flash hazard assessments and analysis are conducted to determine what personal protective equipment you should wear when performing certain tasks. They also help to determine the arc flash boundary, or the distance that must be maintained between you and any equipment where an arc flash might occur. If you are not authorized, do not approach equipment when the arc flash hazard boundary is active. The boundary extends in all directions from the energy source, like a 3-dimensional bubble. It is only active when someone is performing a task with or on the electrical equipment. To work within the boundary, you must be trained, authorized, and dressed in the required personal protective equipment.
Well, the personal protective equipment, specifically the gloves, can be very restrictive and frustrating, but it's a necessary part of the job.
The PPE we use isn't just to make our jobs more difficult, it's to make sure we get home safe at the end of the day.
You cannot predict that unpredictable event or circumstance, so the things you want to make sure you have the PPE clothing on, and secondly, you put as much space between you and where that piece of electrical equipment is. That unpredictable event can happen, so just don't take that chance. Let's go home in the same condition that we came in the morning.
To make yourself a valuable member of the masonry crew, you must understand not only the duties of each member of the construction team, but you must familiarize yourself with the operation of the equipment on the job sites. Keeping the bricklayers supplied with the materials they need and close at hand is key to an efficient operation. And bricklayers rely upon material handling equipment to make that happen. Forklifts are the most widely accepted method of quickly placing large amounts of materials within the reach of the mason or bricklayer, who then places that material in its final position in the building. The masonry construction industry is highly competitive. The job often comes down to time is money and how quickly one man and a machine can do a task. By doing your part to keep the job on schedule and on budget, you allow your employer to stay in business and keep you employed. However, safety should never be sacrificed in order to get the job done faster. Countless forklift accidents have occurred when the driver was taking shortcuts or rushing to beat a tight deadline. A good forklift driver not only is skilled at operating his truck, but he routinely works safely. Because during the past years there has been a growing demand for forklifts on masonry job sites, forklift manufacturers have continually made improvements to their products. These advances in technology and design have resulted in a line of rough terrain forklifts that are easier and safer to operate. The rough terrain forklift is designed to perform in very irregular and/or muddy terrain because of its axle height and four-wheel drive capabilities. On some models with extended booms, rough terrain forklifts can place materials farther and higher than can be safely accomplished using traditional mast-type forklifts. Designed for functionality on a masonry construction site, rough terrain forklifts have, for the most part, helped to create a safer and more efficient worksite. As larger, more efficient, and more expensive machines are developed, the demand for proper training increases. Employers and unions must ensure that the operators of such equipment are properly trained in operating techniques, safety, and maintenance. Specialized union training programs are essential to providing skilled laborers. Just one accident or unnecessary breakdown because of carelessness can cause delays on the job and damage to materials and equipment. Due to the size and weight of the material handling equipment and of the masonry material itself, an accident can have tragic consequences. Operators and co-workers have been severely injured, and some have lost their lives. That is why regulations and OSHA standards exist, to protect employers and laborers from unskilled mobile vehicle operators. Operators of industrial trucks, such as forklifts, are required to be properly trained and to show proof of that training before they get behind the wheel of these powerful vehicles. Carrying a certificate card like the one you will receive for successful completion of this course is a way of demonstrating that you have completed the proper training. In subsequent programs, you will receive training on the proper operation of rough terrain forklifts and how to inspect and maintain this equipment. This introductory program stresses the importance of safety when operating a rough terrain forklift. It may sound like a cliche, but the fact of the matter is that safety should always come first on the job site, not just for your sake, but for the sake of your coworkers and employers as well. The most important part of the safe operation of a forklift is you, the operator. History shows that most forklift accidents are usually caused by human error. The good news is that you can prevent the majority of all accidents through your own awareness and attitude. Safety involves thinking and using common sense every minute you are on the job. Many accidents happen because the operator uses a forklift in need of repair, travels an unsafe route, carries unsafe loads, or uses other unsafe operating techniques. Every one of these situations can be prevented. Accepting responsibility for the forklift's operation and condition is one of the first steps to becoming a safe worker. You should never assume that safe work practices are someone else's responsibility. By taking the responsibility to inspect and to do regular maintenance on the forklift you will operate, you help to keep breakdowns and related accidents to a minimum. You should strive to become a professional at what you do. Under no circumstances should you come to the job under the influence of alcohol or drugs. Doing so puts your safety in jeopardy, as well as the safety of others around you. Showing up for work intoxicated will also likely get you dismissed from the job. You should never operate a forklift unless you have been properly trained and authorized to use that specific piece of equipment. Proper training includes completing a general forklift training course, becoming familiar with the operation manual provided by the manufacturer of the forklift you will be operating, and supervised operation of the forklift you will be using before you operate it in an unsupervised job situation. The authority to operate different types of equipment should come only from the employer responsible for that equipment or from an authorized supervisor of that company. If you haven't been trained to operate a piece of equipment, do not operate that equipment. As stated earlier in this program, safety is an attitude, and the best way to form a positive, productive attitude about operating your forklift is to develop safe work habits. Climb on and off the forklift properly. Use only the grab irons or steps provided. Never use the control levers to pull or steady yourself. This could be dangerous, since moving the controls can activate hydraulic systems and cause a part of the forklift to move unexpectedly. Anything in the way of those moving parts, such as your hands, arms, or legs, or other workers, could be crushed. Always start the machine while sitting in the operator's seat with the seat belt fastened. Never operate a forklift from any other location. Keep your hands dry and free of oil and grease. Get in the habit of wearing work gloves. They offer more protection. Do not wear loose or ragged clothing. A loose or dangling object can catch in moving parts and pull you into them. Never reach through the mast or through other pinch points. Keep your hands and legs within the operator's compartment. Draping your leg over the edge of the machine may be comfortable, but it is very dangerous. Wear your hard hat when there is a danger of overhead hazards. Be especially careful in areas where loads are being lifted overhead. The forklift's cage is a strong and protective device, but objects can fall through the cage onto the operator. When operating, wear your hard hat. If you are working in outdoor areas in windy conditions, eye protection is a good idea. Safety glasses should be worn indoors as well. When mortar is being mixed or other particulates are airborne, safety glasses can protect your eyes and help to prevent accidents. Eye protection can also be effective when placing an overhead load. Many times, sand or other small particles fall from the scaffold or the load itself and can drop into your eyes. Wearing eye protection can prevent this. Don't forget, forklift safety applies to those working around the forklift as well. Always make sure that other workers and bystanders are aware of the danger of an elevated load or raised fork tips. As the forklift operator, you must consider them your responsibility when others are in your area. Never allow them to stay within the danger area. In order to be the safest operator you can be, you need to develop your operating skills. The skills necessary to become a safe, smooth, efficient operator can only come from experience and an understanding of the principles that apply to the forklift. These principles are leverage, center of gravity, and momentum. Think of your forklift as a lever on wheels. Like a lever, there is a limit to how much weight the forklift can lift. Factors which affect the weight of the lifting load are the weight of the load on the forks and where the center of the load is, the length, design, and weight distribution of the lift, and the location of the pivot point, which in most cases is the front axle of the machine. To understand the concept of leverage, think about the teeter-totter or seesaw commonly found on playgrounds. When two children weigh the same and sit at an equal distance from the pivot point, the teeter-totter will remain level. But if a heavier child sits at one end across from a lighter child on the other, the heavier child's end will lower to the ground, raising the lighter child into the air. The only way to level the teeter-totter is to move the heavier child closer to the center or pivot point. This same principle applies to safely moving a load with a forklift. The forklift can lift more weight when the forks are retracted than when they are extended. When the forks are extended, the pivot point shifts forward, making the forklift easier to tip. The load chart reflects this. It shows the relationship between boom length and the amount of weight that can safely be lifted at that length. As an operator, you must also understand the principle of the center of gravity. When the forklift has no load on its forks, its center of gravity is to the rear of the machine due to the heavy counterweight. When a load is lifted with the forks, the center of gravity moves forward toward the pivot point at the front axle. As the boom is extended, the center of gravity continues to move forward. When the boom is raised, the center of gravity also rises. As long as the center of gravity stays on the opposite side of the pivot point from the load, the forklift remains stable. However, if the center of gravity moves past the pivot point to the same side where the load is located, the forklift will tip forward. Comparing the load weight to the load chart will help you avoid this. Simply put, the closer the load is to the ground and the closer the load is to the forklift, the greater is the stability of the forklift and the load. The tipping potential increases and stability decreases the higher the load is raised and the farther the boom is extended. A load carried high with an extended boom presents the greatest potential for tipping. The operator of the forklift also needs to understand the principle of momentum. Momentum is a force caused by the movement of an object. Once an object starts moving, especially a heavy object, the harder it is to stop it from moving. For this reason, sudden stops or turns at high speeds can cause the load to come off the forks or the forklift to overturn. The operator can easily control the effects of momentum by keeping speeds at a reasonable level and by performing smooth starts, stops, and turns. Leverage, center of gravity, and momentum must be considered at all times by the operator in relation to the stability of the machine. We've already seen how a forklift can tip forward if too heavy a load is lifted up and extended out. A forklift can also tip to the side if a load is carried with the boom extended out and up and a tight sudden turn is made. If the load is held very high, the slightest turn can cause side tipping. Travel with loads in a low position whenever possible. Also, don't extend the boom with a load until the forklift has come to a stop and has reached the location where the load must be placed. So remember, you must always be alert to changing job site conditions, the other personnel and machinery around you, and the principles by which a forklift operates. A common-sense, professional approach to your job, as well as experience gained in the operation of the machine, will help you to become a competent, respected forklift operator.